Hello everyone. So today is going to be our day 18 of the DSA challenge I took. And the question that we're going to solve today is reverse pairs, right? This question. So this is the question. Let me open it. Let me open it. Can you draw as well? Great. Yeah. So the question is a hard type question. Now, why is it hard? There are a couple of reasons, right? So first upon is that you have to solve it in less time complexity. That is something that we have been doing in all of the questions that you do not stick to your brute force approach. To come up with that approach, right? You need to have to solve this question for. If I could find yeah, this inversion of right, where if you remember, if what we did was count the inversion where a of I is greater than a of j, right? And you can obviously see the hint that the prerequisite is merge sort. So now I think you already know by now, like which question am I talking about? It's the same question where we used merge sort and we calculated the conditions where our a of I is greater than a of j, right? Where I is less than j. Don't worry. I know these are jargons, and you won't be able to understand in your imagination. You will have to see the question first. So let's understand what the question is. Given an array, integer array num, return the number of reverse pairs in the array. Reverse pair is ij, where zero is I and j is greater than zero and less than nums of length, and nums of I is greater than two into nums of j. Great. So if I can copy any one of it. So if I copy this and I paste it here, right? I paste it here. I can take black for now, right? Great. So what does the question say? That a of I should be greater than 2 into a of j, right? Now what does I and j means? It means that if you're standing at here, your the other element that is should not be equal to this particular index, right? So I and j should not be equal. They should be separated. They should be different. And a of I, that is, if I'm standing here, right? I don't think I will find. Oh, let's just say if we are standing here, if my I is here and my j is somewhere here, right? So if you can see, 3 is greater than 2 into j. What is that array of j? It is nothing but 1, right? So 3 is greater than 2. This is for sure, right? This is for sure. Uh, Great. So I think very easier to understand the brute force. It is going to be same as count inversion. What I'll suggest you guys is you should go and see my video of inversion of array. I have explained there as well. So this brute force is going to look like the same thing. So if I paste it again here and I will start my I will keep my I here. Okay. I will keep my I here. Now I always have to be lesser than J, right? So this is my I. This is very this is something, right? If you remember, if you see the pattern every time in almost all the questions, I make you look up to the constraints and as well what is given in the question. Obviously, that is something that you'll always see. But again, you have to see the constraint as. But here I notice that this is written here only. So see, if I start my I, people people generally what people do is they forget to read this line and they just jump onto this line, and what they want to do is they just apply it. See, I will start from zero and will go till n minus one. That is for sure. That is for sure. Great. I can take a count which is nothing but zero right now, right? Now the good question would be, where should I start my J with? The answer is I should start it with I plus 1. Now, why not I and why not 0? Why not 0? First of all, the first point is you cannot start it from 0 because I always have to be lesser than J. And if you start from 0 and let's just say your I is somewhere at any position, 3, and you are starting from 0, right? Is that condition satisfied? Even if you get the answer, is that situation satisfied? No, right? So first of all, you should start it with I and I plus plus. This is for sure. Now, why from I plus plus only and why not I? Because here it is simply given that I and J are not equal. They are not equal. I will always be less. J will always be less. I plus 1, simple. Will go till n minus 1. If our condition, sorry, what is our condition given? This condition, right? This condition. If I just, you know, can bring it up here. If this satisfied, then count plus plus, right? And at the end of the day, you just need to return the count. Return this count. Great. What is the time complexity for this? Okay. If I take, if what I can do is I can simply say that, hey, I am running two loops, though this loop is running starting from I plus 1. That is for sure. That is for sure. But at the end of the day, you will always write it as n only, O of n only, right? So what I can do is I can say that, hey, to couple of loops, so O of n square and phase complexity, nothing. O of 1 constantly. Great. No problem. Uh, now, now you need to think of something that is lesser than O of n square, right? That is lesser than O of n. Now, how can we see? How can we look up to it? Uh, okay. Now your approach should be, hey, O of n square is greater than O of n, greater than O of log n, right? Greater than O of n log n. So these three things can be my answer. I mean, my optimal answer should be should be in one of these. The time complexity. Yes, that is fine. Now, okay. Let's before getting into or how our brute force looks like. I will write three. I will write two separate arrays, and then we can discuss the intuition of this of the optimal solution, right? So I have 6, 13, 21, and 25, right? This is going to be 1, 2, 3, 4, maybe 5, maybe take 11 also, maybe take 11, 9 also, maybe take 11 also, right? Great. Now I will start my, let's just say, this is my left part, this is my right part of the same array. Now assuming these are of same array, okay, this is of same array. That means I can keep my pointer at any position of time. So at any point, so they will point at the end of the, they are inside my single array only, right? So if I have to say that 3, if I have to say what is array of 4, you will say that, hey, it is 1. It is 1. Why? Because 1 is a part of that simple array. So you don't need to worry about it. Okay? Now, if I remove this for now, great. So what I'm going to ask about from you guys is that, hey, you have to choose one element from the left part and one element from the right part. You cannot say that, hey, I am choosing both of the elements from the same part. Fine, great. Choose one element from left and choose one element from right. And what you have to do is you have to do the same thing. That is this situation. Find me this situation where one is from left and one is from right. So array of I should be from left and array of right should be from, sorry, array of J should be from right part. Understood? Great. Now notice one more thing. This array is sorted. This part is also sorted. This part is also sorted. So you can take this in your advantage, right? Okay. If let's just say my I put my I counter here and J pointer here, right? Okay. So 6 is greater than 6 will form a pair with 1. Why? Because 6 is greater than 2. That is 1 into 2, right? So let's just say I say that 1. Okay. 6 is going to, let's just say I wrote down I and I wrote down J. Great. Uh, Now again. Will 2 form a pair with 6? Yes, because 4, that is 2 into 2, is lesser than 6. So, will 3 form a pair? You will say no. Why? Because 6 is not greater than 6. It is equal to 6. So, this is done. Great. Now, I will wait for 13. I'm not moving my pointers right now because I am keeping it for, I'm keeping this part clean for you guys to, make you finally understand how the approach should look. Great. So, but 13 will form a pair with 1 and 2 for sure because it is forming with 6. And 13 is greater than 6, so why not? Will it form a pair with 6, 3? Yes. Will it form a pair with 4? Yes. Will it form a pair with 5? Yes. Will it form a pair with 9? No. Great. No problem. 21. All these elements, comma. Will it form a pair with 9? Yes. Because 18 is less than 21. So 9. Will it form a pair with 11? No. Why not? Because 22 is not less than that. Right? So close. 25 now. All these pairs, comma, including 9, and will form a pair with 11 as well, right? Will form a pair with 11 as well because 22 is less than 25. So this is how many pairs that we can find, from this thing. So 6 will form 1, 2, and 13 from this, 21 from these, 25 from these, and all. Right? But there is a pattern to look upon. There is a pattern to look upon, right? Similarly, there was a pattern in count inversion where we took one element from left and one element from right. But there what we did, I, when we were standing at 6, when we were standing at 6, okay, what I did was, I would say that, hey, if array of I is greater than array of j, this was the condition in count inversion, right? If you remember, it was a of I should be greater than a of j. Sorry, should be greater than a of j. This was a simple condition. Yes. So if 6 is greater than 1, right? If 6 is greater than 1, then all the elements will be greater than 1. Fine. If 13 is greater than, anything, right? Great. But now we have to modify it a little. We have to modify our approach little. Now, what is that modification? We'll see, right? So if I just, remove these couple of things, remove this as well. This as Great. Okay. Mm, let's just say I put my I counter here and J counter starting from here. That is okay. I will not get into, in the future right now. So 6 make pair with I. Yes. J comes here. Yes. So my count is going to be 0 right now. Right now, right? Will 6 form a pair with 3? You will say no. So what you add is you add. So let's just say you add J, your J pointer is here, right? Your J pointer is here. You will say that whatever is my J, I will subtract it by, what is my J? 0, 1, 2. I will just say whatever my J, wherever my J pointer has stopped. Now, where has your J stopped? At second position. So you will add plus 2. Because these 1 and 2 will for sure make pairs with all of these. That is fine. That is for sure. That is for sure, right? So J is here. I bring my I to here. I bring my I to 13. Do I need to check for 1 and 2? You will say no. You will say no. Now why am I saying no? Because hey, if it was forming with 6, if it was forming with 6, that is for sure that it will form with 13, right? So why to even waste my time there? I will just keep my J here, start from 3, and then I will loop ahead. So 3 forms J here, then 4 also, then 5 also, right? But not 5 also, yes. Will it form a pair with 9? No. So here is my 9. So 0, 1, 2, 3, 4, right? Sorry. 1, 2, 3, 4, 5. So 5 pairs, right? 5 pairs. Count again 2, 4, and 5 here. Can I add a plus 5? Can I add a plus 5? Yes, I can. Yeah, I can. What was my situation that I will add whatever wherever my j is. Remember, when I'm saying wherever my j is, I am not counting it. I am not counting that particular element. I am not counting nine. I am counting all the other elements before it. All the other element before it. Right? Let's just not get into the code part yet. We'll see. So 9 cannot form a pair with 30. I bring my I here at 21. Will obviously form till 5, that is for sure. Remember, here we wrote that hey, it will definitely form with 5, but also now it will form a pair with 9. Now j comes here. Fine. Will 11 form a pair with 11, with 21? You will say no. So I'll just add 6 and I will increase my I count. Great. 25 forms pair with all of these plus will it form pair with 11? Yes. So I will add 7. Simple. So these many pairs I can find from these two particular arrays. And remember in the starting, I told you something that hey, you don't have to assume these two different arrays assuming that these two arrays are a part of the same array. They are eventually going to be the same array, right? So this is what we did. Now, one more thing that I mentioned was the arrays are sorted. These two arrays are sorted. Great. Let's quickly, what I'll do is I'll quickly write down this here, right? I'll quickly write down this here. Let's just discuss. I hope, sorry, no, I did not mention it here. I hope by now you already know that why we are using our word sort, because we need to sort the left and the right part. We need to divide it somehow that all my subparts, right? All my subparts are sorted, and then I can find the pairs. That is fine. That is the same thing that we did in count inversion. This is the same thing that we are doing here, but the situation kind of, a little bit changes here and there. Okay. So this can be divided into two. Now, what was my mid? It was, let's just say I keep my low here and high here. What is my mid? Mid will be somewhere here. So mid will be at 2, right? So um 0, 1, 2, 3, 4. 4 divided by 2 is 2. So here. So I will take from 0 till till the mid, if you remember. So 1, 3, 2, right? And this will this will be 3 and 1. Great. What was the mid? Mid will somewhere be at 3. This is my low. This is my high. What is this? This will be 1 and 3. This will be this will be nothing but 1, 3. Let's write down for this as well. This will be 3, 1. Great. Yeah. Again, let's start. Let's now do this thing, what we did, right? These two are separate arrays, but are sorted in their manner, but are sorted in their manner. So I can take a red here, you know. I put my left pointer here, right pointer here. I will say, is my left greater than my right? Obviously, array of left and array of right. You will say no. I will move my left pointer ahead. I will move my left pointer ahead. This moves here. No, nothing found. Nothing found. Great. So count remains 0 only. Count remains 0, right? And the merge sort will do its part. What will it do? It will go back, return. This becomes 1 and 3 only. Sorry, I didn't have to make it, right? Now these two are separate. These two are separate, right? I keep my left pointer here and right pointer here. Will one form a pair with two? You will say no, it will not. It will not, right? So I will increase my count if I had to. I will what I would have done is I would add all the elements before this to count, and then I would increase my left here. So left comes here. Does 3 form a pair with 2? So 2 into 2 is 4? No. No. count remains 0 only, and left ahead moves ahead, nothing found. Then again, this will do its work. That is 1, 2, 3, right? Great. Now this part, right? Put my left pointer here, right pointer here. Right, one form a pair with 3. You will say yes, it will, yeah, it will. So I will move my right pointer here. Now nothing found, nothing found. What is my R here? What is my R here? It is nothing but uh second position of that array. Second position of that array. We'll get into the code. We'll get into the specifics like how to write this part. But I hope you understand this. I hope you understand this. Okay. So I will. What will I? I will add one, right? And this goes back. This returns. This becomes 1, 3. These are two separate arrays now. These are two separate arrays. Great. Is now putting my left pointer here, right pointer here. What is my 1? Is 1 going to form a pair with 1? No. Moving my left pointer ahead. Will 2 form a pair with 1? No. Because 2 is not greater than it. It is equal to 2. Right? I hope I explained. 3 forms a pair with 1? Yes. So moving my right pointer here. Will my 3 form a pair with 3? No. Obviously not. Right? So what will I do? I will increase my left pointer here. Sorry for this. This should be right here only. And left, I cannot find anything. Okay, so what will I do? I will just add 1 plus 1 here. So it becomes 2, right? It becomes 2. And again, array does it. The merge sort does its thing. So 1, 1, 2, 3, and 3. So this is our final array, how it looks like. But this was not what we want. This was not our, thing to do. It is a byproduct of our algorithm. It, that the final array is sorted now, right? This is a byproduct. Great. What is the count now? Finalizing count is 2. Is this what we required? Yes, right? Yes. Okay. Now another thing to notice here, I will change my, what I can do is I can, make it maybe pink, doesn't matter, right? So okay, this is my low. If you remember, this is my low. This is my mid. This is my mid plus 1, and this is my high, right? This, I think the font is a little, can I take this? Maybe. Yeah, no. Seems same like, okay, I'll take this. So low is here, mid is here, mid plus 1 was here. If you remember, in merge sort, you should have merge sort on your tip. That hey, low will be here, high will be here. This two will be m. So 3 and 1 will be starting from mid plus 1, and then it will go till here. Now, had I moved my right pointer at this side, had I moved my right pointer from this side, what will I simply add into my count? Where is my count? Here is my count. Right? Here is my count. Bear with me. Bear with me. So let's just say my right is here. Right? Right is here. Doesn't matter. Let's just say my H was somewhere here. Doesn't matter. And these are the elements that are there. Right? These are the elements that are there. Okay. We'll see. We'll see. My right pointer is nothing but, let's just say this is my right somewhere. This is my mid plus one somewhere. Somewhere. There are a couple of elements in between. In between, there are a couple of elements. And this is my final array where H is here. Right? This is my mid plus one. And some elements, and then somewhere here is my right, and at the end is my H, that is high. Right? I need to add all these particular elements for the particular left pointer. That is for sure. Okay. Can I write right minus mid plus one? Will it give me all these elements? Yes, it will. Yes, it will, right? Mm, did I explain somewhere here? Mm, 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 mm. Maybe not here, maybe not here. But yeah, I mean, I hope you understand this. This is easy to understand, but you still need to, come up with this in an interview. I know you don't have to mug it up. Right? This is thumb rule. You don't have to mug it up. You have to think. My right will be moved. My right is a variable that will be moving. It will not be at a constant place. But my mid plus one will be at a constant place, and it represents zeroth index in this particular right part. So there are two parts of the parent, right? Left and right. This mid plus one is the starting of my right part. That is fine. That is short. And right pointer. This right pointer is the one that is moving. Is the one that is moving. So get the difference of right and mid plus one will give me the elements that I've already traversed, that I've already seen, and will definitely form a pair with the particular left parts element with particular left part element, because I know that hey, if let's just say if here was maybe 50 and 51, right? If 50 is forming a pair with all these elements, 51 will definitely form a pair. Similarly, we'll definitely form a pair with all these because these are sorted, right? Great. We have achieved all this thing. What I'll do is I will copy. So merge sort, right? Merge sort. Where was my merge sort? Lead code, sort and array. This was a question that we did on lead code. I will not write it again, but for you, I think you should definitely write it again because the point is that I did this question before opening the video, and then I already solved it. So I don't think I need to do that right now. So copy, remove this, and let's copy paste it here, right? Same things are happening, but you will notice that the return type of merge sort is right now void. It is returning me nothing. It is just in place sorting my app, right? Now, if you remember in count inversion, I told you one thing that was that you don't have to declare a you know a global variable. What you can do is this is a bad practice, basically, right? You cannot play around with a global variable. You should not definitely. What I can do is I can say that hey, I will assume my right pointer here, no problem, right? I will assume my pointer to be my count to be here. I will return a zero if this is the condition, low is greater than high, right? I will say that hey, count plus is equals to this and count plus is equals to this. There will be one more condition here we'll write, and at the end of the day, I just return my count. And what I can do is I can return what my array merge sort has to return. Now, what will I pass? I will pass nums, I will pass 0, and I will pass nums dot length minus 1. So this is my low pointer, this is my high pointer. Till here, we already know, right? There is one more thing that we need to write. We need to write a function. Now, why do we need to write a function? In the count inversions, if you remember, we did something here in here where left was lesser than high, and if this is a condition, hey, just add to my count. But here you cannot play it around with because you don't definitely know, right? Will it form a pair with all these things or not? Will it form a pair with all these things or not? Right? So we'll just simply write another function. I can now and I can say function count pairs. I will take an array. I will take low. I will take mid. I will take high. That's for sure. Great, great. Uh, I will say that hey, let right is equals to nothing but mid plus one. Let count is equal to zero. No problem. Right. I will say that hey, let I which starts from low. Now, why is it starting from low? Why is it starting from low? If you remember, this was nothing but low only. This was our high, right? This was our high. If in this thing, this was our low and this was our high, when you divide it, this is what it comes. So low plus high divided by 2. That is where we'll find mid here. And from low to mid, we take from this side. And from mid plus 1 to high, we take from this side. So I start from high. I will say that A is equal to mid. Now, why am I taking it till mid? What is this? In this particular array, this is low and this is mid. Do I need to go further? No. I will go till mid and I will say high plus plus. That is short. I will say that hey, if my condition is that hey, if array of low is greater than 2 into 2 into array of right. Remember when I told you that hey, right also will be a part of my array? This is the situation I was talking about. If this is this, I will say that hey, count plus plus. Oh, sorry, not count plus plus. I will not count plus plus. Now what will I do? If you remember, I was just simply moving my right pointer ahead. I will just, or maybe if I don't even have to write, I will traverse my right loop to somewhere. Now, while my right is lesser than, if my right is lesser than or equal to high, and now I can check that hey, array of low is greater than 2 into array of right. Why am I doing this thing? Why am I doing this thing? Like I told you in this situation as well that hey, J was here. You said yes, it forms a pair. I move, I move. Till which point? Till this 3 point where I found that hey, 6 cannot form a pair, and I used to add all these elements which were before 3, right? Similarly, I'm just writing by this, and I say right plus plus. This is fine. Yeah. Now I'll say that hey, count is nothing but count is nothing but addition of all the elements that are there, which is right minus mid plus 1. And this should be right. Now, what is this situation? What is this situation? If you remember, I told you the example, and here we have moved the right pointer ahead. We have moved the right pointer here. So right was somewhere here, and it started from here, and it got here. Now I need to add all these elements, right? So this is what I'm doing. And at the end, hey, why is it not taking count? Okay, maybe some glitch. And at the end of the day, I just return my count, right? I'll just return my count. Now, where should I call this array? Okay. Where should I call this function? I should call it somewhere here, which is nothing but count plus this. It takes your array, it takes your low, it takes your mid, and it takes your high. For sure, for sure. Yeah. Let's try to run. Okay. Maximum call star exceeded. Now, why did that happen? Why did that happen? Okay. Why did that happen? Can try it again. What I'm saying is, uh, count is equal to merge sort this, count is equal to merge sort this, and count is equals to count plus this for sure. Okay. Not adding it here because I'm not even considering this merge thing. What is this merge doing? Is it part? I'm not going to touch it, right? Count pairs, right? Starts from mid plus one, that is short. Count is 0. I should start from low and goes till mid, that is short, that is fine. Right is lesser than equal to high, and array of low is greater than 2 into array of right. Or maybe I can say that, hey, this is, I'm sorry guys, array of I should be greater than. Let's try to run it now. Okay, still getting that same thing. Okay. Still getting that same thing. Count is equals to right count plus this, right? Great, and returning count. I think this is working fine. Not sure why this is not. Mhm. Let's again, you know the drill, right? If you are stuck somewhere, just copy the code and simply go to Python tutor, right? You know the drill now. Let me connect my charger. Great. So this is this, and I will simply call reverse pair. Is it reverse pair or pair? Reverse pair, where I am giving it an array. I'll just give this for now. Okay. I know I'm not printing anything. I'm just returning in the main function here, but doesn't really matter. Okay. Okay. Great. Before even going there, I already found it. So this should be length and not these silly mistakes, right? These silly mistakes you have to avoid. And I am not able to avoid. So let's even close this because it's already accepted. One more thing of one more one major drawback of using JavaScript and not TypeScript is that here you are not checking the type. You're not checking the type. Had I been using, okay, I'm not sure if in TypeScript also dot length would have given me an error that hey length the spelling there is a spelling mistake because num not length with e here and h here are nothing. But okay, yeah, we'll try to submit this. My bad, I think. See, accepted. Great, great. Uh, See, it is hard. It is hard. But for people who already know how count inversion works and how merge sort works, this is not going to be that hard. Oh, right? Why did I say count inversion is something that you need to look upon? Is because you will get the idea from their own. You will get the idea from their own that hey, I need to keep my right part and left part different, and I need to have a sorted left part and right. This is what I'm talking about, right? If you know how count inversion work, you have done that question. If you know how merge sort works, I think this should not be hard. It should be probably medium at math, right? So, yeah, we have done the question. I think what we can do is we can write here. This question uses similar approach like count inversion question with merge sort, but here you don't have to make any change in the merge function, rather make a new function. By the way, I could have done in merge, but again, people say that, by even people, even I say, if developers believe that, you know, to write the best code out there, you need to have function block, right? You need to have everything inside a function, right? Everything inside a function. So that is why we make functions for everything. Make a new function and count the pairs. Keep your left at low and right at mid plus one. And now count all the things that could be there that could form a pair with low element, and obviously all the other element in the right part will uh in the left part after low element will form two. right? Uh, not the best sentence making I can do right now, but yeah, I think I've given myself a hint over here. So save it, mark it as done, and from tomorrow we'll move to two sum problem. I think two sum problem and three sum problem has to be my favorite. I'm not sure why Scriber hasn't put three sum problem here, but I guess two sum and three sum has to be my favorite, right? Um, So we'll I'll just meet you tomorrow with this same with another question called two sum, right? We'll understand why this situation, why two-pointer approach is the most important approach. And I read somewhere, I think it was some person's video. I think he was telling the top five algorithms, or I don't exactly remember. There were few that were there in in DP and by research in DP and trees and everything. But this what do you call two-pointer approach, and one is I'm not getting the exact name. God, but how can I forget it? Mm, sliding window. Yeah, these two these two are one of the top five algorithms that are in in interviews. So I think this should be on your tip that how to understand two-pointer approach and sliding window. So yeah, we'll meet you tomorrow with this question. Thank you so much, guys. I'll see you tomorrow. Bye bye.